Welcome to the video for C2.21. So we're going to look at metals and non-metals in this now. I've split it into two parts. We've got A today, which is chemical properties, and then there's going to be a second video about physical properties. So before we start, we need to think about what our previous knowledge we need to know in order to access this lesson. So we should have learned in year 9 when we did unit C1.1, we would have learned that a chemical change is when a new substance is produced. So we learned about chemical changes being not easily reversed and physical changes being more easily reversed. In Key Stage 3, so in year 7 and 8, we learned that the periodic table contains all known elements. And we also learned at Key Stage 3 that a molecule is a particle made from more than one atom which is chemically joined together. So at GCSE, we need to sharpen this definition up a bit. So it needs to be a bit more specific. So a molecule is a particle made from more than one atom chemically joined together. So that's the first part was correct. But we just need to add this last bit of bicovalent bonds. Because as we'll see in the next few lessons, you can have covalent bonds and you can have ionic bonds. And in a molecule, it's covalent bonds. We're going to explain what that is later in the topic, so we don't need to worry about that now. So our learning objectives for today, we need to be able to describe the properties of metals and non-metals and their position in the periodic table, so where do we find them in the periodic table. We need to explain how metals and non-metals differ in their reactivity, so they behave different chemically, and also describe the reactions of metals and non-metals with oxygen. So first of all, here's our periodic table. So you should have one of these stuck in your book. So periodic table, as we said from Key Stage 3, contains all our known elements. Now, based on where an element is in the periodic table, we can see whether it's a metal or non-metal. So the periodic table is organized in increasing atomic number. And if we do that, then we find that this is the pattern of where the metals and the non-metals are. Now, hydrogen, that on the left-hand side, that single solitary non-metal, if we look back at the periodic table, is hydrogen. Sometimes that's put in the periodic table kind of floating above the middle bit, rather than on the left-hand side. So you can see hydrogen's an anomaly there because it's on the left-hand side, but it's a non-metal. All the other non-metals are on the right-hand side of the periodic table. And then the metals are on the left-hand side of the periodic table. But although we say left and right, really, there's a lot more metals than non-metals. So it's kind of the center and the left of the periodic table is the metals. And then you can see in orange, we've got something called the semi-metals, which are sometimes called metalloids. And those elements have some properties that are metallic and some that are non-metallic. So sometimes they act like a metal and sometimes they act like a non-metal, which makes sense because they're on the borderline between metals and non-metals. So I should have said that metals and non-metals have different chemical and physical properties. So your first task, you need to use your periodic table for this, is to find all of these elements on the periodic table and then put them into the metals or non-metals column in your table. So you need to copy that table down and just put those elements in. So here's some notes you need to copy into your book. So chemical differences. So next lesson we're going to look at physical properties of metals and non-metals. Today we're just going to look at the chemical differences. So metals react with oxygen to give alkaline oxides, and non-metals react with oxygen to give acidic oxides. So at Key Stage 3 you'll have seen the pH scale and you'll have seen a chart and you'll have used universal indicator. And when metals react, we'll do this in more detail in the next few lessons, but when metals react, they lose electrons and become positive ions. And when non-metals react, they gain electrons to become negative ions. Now, we're going to do this in detail. So those keywords like ions and this concept of gaining or losing electrons, we haven't done yet. But it's important to mention here, but don't worry if you don't understand it, we'll do it in the next few lessons. So important difference between metals and non-metals. So metals can react with non-metals, but metals don't react with other metals. However, non-metals can react with other non-metals, and when they do, they form molecules, which, as we discussed, is when you've got a particle which consists of more than one atom that are chemically joined by covalent bonds, which again we'll do later in this topic. So your second task, you need to copy this table into your notes and then you need to complete it using the information on the next few slides. Now, before we do this, you've got to realise that the following is a simplification. So I've just noticed a spelling mistake on there. The simplification, there's a missing A. So if you take A level and we do this, then you'll see it's a bit more complicated. So at GCSE, we talk about the oxides being alkaline or acidic, but it's more complicated than that, because in practice, what happens is the oxide doesn't dissolve in the water, it reacts with the water, and that gives a soluble alkali or a soluble acid. But for the purposes of GCSE, we just say the oxide is alkaline or it's acidic. So if we look at sodium, so hopefully you've seen this done in the lab. So sodium before, so if you take sodium metal, it's stored under oxygen. Sorry, it's stored under oil because it reacts with oxygen. But if you cut it and it's fresh, it's a nice shiny grey metal. It has kind of a dull layer on it of sodium oxide if it's been allowed to react with the air. When you see it reacting with oxygen, so if you place a piece of sodium in the Bunsen burner, it goes that nice kind of orange yellowy flame. And that results in forming sodium oxide, which is a white powder. And if you put that white powder in water, it reacts with the water to give sodium hydroxide, and you get a pH around about 14. So if we put universal indicator into that solution, it would go kind of bluey purple. So magnesium, so you've probably all seen magnesium, you've probably burnt it in a Bunsen burner before, so it's a shiny metal. It's a bit dull when you first get it. Sometimes you have to put some wire wool on it to get rid of the oxide layer on the outside. But it's in a coil there on that picture. Sorry, I couldn't find a better picture. And it's just a typical metal, so it's shiny and it's grey. When it reacts with oxygen, you get a bright flame, and it's a bright white flame. And then this makes a kind of white powder, which is our magnesium oxide. And if you put magnesium oxide in water, it's not very soluble. It's not as soluble as sodium oxide. So it doesn't react with the water as quickly. So, but if you leave it for a while, then you'll see it kind of going bluey, purpley, if you've got universal indicator in there. But that's a lower pH because the magnesium oxide is not as soluble as the sodium oxide. Then you get a lower pH. So the pH is around about 10. Now, if we react carbon, so carbon in the form that we use in the lab is a black powder. When it reacts with the oxygen, you just see kind of reddy orange glow. And when it's fully reacted, it turns into, so carbon reacting with oxygen gives carbon dioxide, which we've all heard of to do with climate change and greenhouse gases, and we'll do that later in your GCSE. And carbon dioxide is a colourless gas, so you can't actually see it when you've created it. Now, if you take carbon dioxide and you dissolve that in water, you get an acid, and the pH of that is around about 4. So if you had universal indicator in there, it would kind of go orangey red. The last one is sulfur. And if we've done this in the lab, I think this is the nicest of them, although the magnesium is quite spectacular with a bright white light. So sulfur is a yellow powder when it as the element. So before we stick it in the Bunsen burner, it's a nice yellow powder. When it burns and it reacts with the oxygen, you get this nice blue flame. So it melts first into a red liquid, and then when it starts burning, you get this nice blue flame. Now, when you put it into a gas jar, you can see, so that's not a very good picture there, it's kind of misty fumes of the sulfur dioxide gas. So it is a gas, but unlike carbon dioxide, you can see it because it's misty fumes. And we have to be careful with this because it can set off, it can trigger asthma attacks. And when you dissolve the sulfur dioxide in water, you get sulfurous acid, and that's got a lower pH than our when our carbon dissolves in water, carbon dioxide dissolves in water. So that gives us a pH of about 1.5. So you've got a possible extension task now. So you could write word and symbol equations for each of the reactions that we've seen. So we haven't done aluminium, but an example would be aluminium plus oxygen to give aluminium oxide. So you're just getting, anytime you react an element with oxygen, you just get the oxide. So it just becomes the element's name and then the oxide, and there's only one product. So if you're going to write a word equation, all you do is replace aluminium with the element name. So if I had potassium, it would be potassium plus oxygen to give potassium oxide. Now, to write the symbol equations, you're going to need to look up the chemical formula of that element's oxide. There is a way of So some of these you need to remember, and some of them, the ionic ones, you can work out what the formula is. Some of the covalent ones you can as well, actually. But we will learn how to write these formulas without looking them up in later lessons, so don't worry about that. For now, if you want to write the simple equations, just look up on Google the formula of them. So our last task, task 3, is an exam question. So this is a real exam question from GCSE. So this exam question is asking, element Z burns an oxygen to make white clouds of its oxide. Describe how you would test the oxide to determine if element Z is a metal. And that's worth 3 marks. So I want you to pause the video and answer this question now, and then the answer's on the next slide, and you can mark your answer. So our answer was we needed 1 mark for each of these. So you need dissolve in water for 1 mark, test the pH with universal indicator for the 2nd mark, and then the 3rd mark could either be universal indicator would turn blue or purple, or that the pH is greater than 7.